So now I'm going to get into the evidence-based learning that can actually get us through that hippocampus into our long-term memory. Firstly, chunked. I talked about there being 4 chunks of memory. We know that if I say, what's an animal? Just name any animal. A dog. And name a place. Melbourne. And name an object. A ball. And name a number. 5. So what was it? So dog, Melbourne. I can't remember it now. 5 and... Ball, thank you. So if I, right now it's not hard to remember, but if we keep going with this and I ask you that in a few days, you'll probably forget it. You can remember it better if you actually chunk it. If you actually and use your visual cortex, which is massive, it's great, it's brilliant. It's one thing that you should really use a lot in terms of memory. If you actually imagine a dog holding a ball, maybe 5 balls, juggling them in the city centre of Melbourne, that's going to actually stick in your brain much more because you're actually chunking it together and you're using your visual cortex. Environment is something that we ignore, particularly in terms of formal learning. We actually learn with our bodies, as I mentioned before. So one experiment which I think gets this across is they got deep sea divers and they did flashcards with deep sea divers. They got some of them to learn these flashcards above water and some of them to learn below water. And then they learnt the flashcards underneath the water. That's where they learnt did their learning. Then they were tested above water and tested below water. The ones who were tested below water did better. You may have heard these tips like, now these days kids that you'd say, don't just sit at your desk and learn in that one environment because if you've got to recall it in an exam, it's going to be different. Some people use gum. When they're trying to learn something important, they chew a particular sort of gum and then when they've got to recall it, they chew that gum again. You remember the experience. You don't just remember the particular information that you're reading. Space repetition is a really big one. It's massive. So if you've got a particular bit of information that you need to learn, there's even, this is so tested now, they've even got graphs about saying, if you need to remember this in a year, this is how you should space this repetition if you've got this much time. There are actually formulas around it. We know the forgetting curve happens. That's part of our brain. That's a really important part, actually. I really feel for the people who don't have a forgetting curve, and there are people like that. But what happens is as the forgetting curve goes down, if you actually hit it with another sort of refresher session, it's going to stick much longer. It feels like you're learning slower, and it's true, you are. If you just do like 10 hours of swatting, of like cramming, you're going to have immediate recall of that information for the short term much better. But you will know, everyone's crammed for an exam, and you lose it within a few days. So space repetition is massive. Focus is huge. I mentioned the difference between sensory and short-term memory was actually attention and focus. Part of that too with focus, there's a lot we could talk about with focus. I really like John Keller's ARCS model, ARCS, and I'll talk a bit about that later actually, if I have time. Mental models are massive as well. We know this, it's about prior knowledge and how you relate what you're seeing to and what you're learning to your existing knowledge. I like to use the metaphor, I think it was Barbara Oakley, who's a really brilliant writer in this field, who talked about an octopus. And so, when you've got something in your working memory, you think of it as an octopus body and it's thrashing around, all its tentacles are thrashing around and it's trying to grab onto stuff in your existing brain, in your long-term memory with its tentacles. If it can grab hold of something, then it can pull the rest of its body through. If it can't, if it has no relationship to what you already know, then it's really difficult to get that working memory back into your long-term memory. Interleaved is one that people... I think it's probably less acknowledged, but there's a lot of evidence around this now that the example I use is the Kerr test, and there's variations on this. And I've got references, by the way. If people are interested, they should probably contact Georgie and get my references through that. But the Kerr test is something where they did, in the 70s, they got kids to actually, 8-year-old kids to throw, and I always change the numbers on this because my memory is actually shocking, so the numbers aren't right. But they get kids to actually, the aim was to say, throw a beanbag into a bucket 4 feet away. And they got one group of kids to do it 4 feet, 4 feet, 4 feet. And they got another group of kids to do, I think it was like 2 feet and 7 feet. And just that, they never actually did 4 feet. And then at the end of a month or so, they tested, and the 2 and 7 feet were better, more effective at getting the 4 feet than just the ones who just did the 4 feet. And the reason here is, again, hippocampus isn't paying attention if you're bored. If you're just doing 4 feet, 4 feet, 4 feet, and you're yawning and just doing it, at a certain point, your hippocampus isn't paying attention. If you're having to think, okay, 2 feet, and if there's variation on the fact, you're actually having to pay more attention to it. You're having to actually work your brain on it. as an aside, and I wouldn't recommend this, they did even a test where they had lovely fonts like this, Helvetica or whatever, where you're reading content, and then they changed it to fonts that you could barely read. And people actually remembered the fonts you could barely read more than the fonts that you could read. That's not an argument that we should have bad fonts in our learning, but it's just, I think the message there is that if you work to try to engage with the content, you're going to make it stick more. Retrieval is a biggie. Probably the two biggies here. I mean, I didn't put sleep in. Sleep is actually massive, but besides sleep, there's retrieval and spaced repetition, probably the two biggest ones if I was to have to rank them. And retrieval is about, rather than just recognizing content, it's about pulling it back. So when you've got it out over there in long-term memory, when it's sitting in long-term memory, you might see something, like you might walk out of this today and you might go and see something about brain functions and about the hippocampus and the role of the hippocampus, and you'll recognise it because it's sitting in your long-term memory somewhere, and you'll say, yeah, I know that, and you'll put it away. But if you actually had to leave here and explain it to someone in 2 days, and frankly, if you knew now that you were going to explain it to someone in 2 days, you'd actually be learning much more effectively. There's no illusions of competence when you've got to retrieve. There is illusions of competence when you can recognise, because you can say, yes, I recognise that, that's familiar, I know it, and I can do it. But if you've got to pull it yourself from nothing, then there's no denial. Basically, there's no illusions of competence. So that retrieval is massive. It's been shown that one of the worst things you can do if you're trying to learn something is just read it over and over again. Even writing notes and fluorescent pens, pretty useless. They talk about using things like the Cornell method, where rather than just writing notes, you're actually asking questions in the columns. So then when you scan it later, you can actually ask yourself the questions. You're trying to retrieve it, then you can go into the stuff to actually find out the answers. You learn a bit slower, but you'll learn for longer. Multi-channel, this is a biggie because, as I mentioned, long-term memory is massive. Over here in your sort of short-term working memory, it's very limited. Your cognitive load in that working memory area is very, 4 chunks. Also, if I had what I was talking about here written in words and I was explaining it, that's shown to be worse than if I was just talking about it with no visual aids, or if I just had a visual aid explaining it. You're better at just reading it or just hearing it rather than trying to do both. Suddenly the channels through your brain are overloaded. Is that 20, Morgan? Thanks. So just focus on one channel at a time and support it with supplementary channels. So what I'm doing here with the images. Also related to that, and I won't go into it now, but you may have already heard that learning styles are a sham. I'll just put that out there. That, people who say they're visual learners, and I have preferences around visual, or some people prefer tactile. There's now the growing body, not all evidence, but the growing body of evidence of putting people through learning interventions based on visual and looking at their preferences and trying to line up the results. It hasn't held true. So people say that they have particular preferences, but really I think the focus is, from an L&D point of view, is to try to create experiences, trying to really know that people learn through their bodies, try to actually activate different parts of that experience, but not all at once, trying to have different foci. And finally, metacognition at the top, which is a big word for basically saying thinking about thinking or learning about learning. Carol Dweck, D-W-E-C-K, is a fantastic writer in this field, and she's from Stanford, which makes everyone listen to her. But she's got great stuff to say here. She's done a lot of work, and basically she's written books. I think it's called Growth Mindset, and it relates a lot to kids, but also adults. So basically, what she showed was that. I think this test was with kids. I can't remember. She's done with both, but I think in this instance it was kids. If kids actually had a growth mindset, basically, if they understood the principle of neuroplasticity, if they understood that their brain could actually grow and learn, they were going to learn much, much more effectively than someone who thought their brain was a fixed piece. Yeah, it's a massive piece. And one of the big things we do is try to empower learners. I think that's one of the challenges here, this metacognition piece. And as Simon mentioned, one of my big areas of interest is motivation and getting that learner on board. It's because today, as you know, your business will probably come to you and say, okay, we've got this problem, fix it, give them training, give them the magic pill, and then we'll walk out of there. And then when the magic pill doesn't work, they come and say, why didn't the magic pill work? Why didn't the 3-day training work? Or why didn't these e-learning modules work? And I guess what we're trying, I think people, I've just chatting to people before this started, and I think people get in this room that what we're trying to move away from trying to offer a magic pill. We're trying to really empower the learner to take responsibility for their own learning, and we're almost trying to provide that support for them on that journey. And part of that big piece is metacognition. It's about convincing the business that this has got to happen, that continuous learning is actually the framework now. It's not about just sticking people in an event and they'll be fixed. It's about trying to develop continuous learners. But also for the learner themselves, we've got to empower them to understand that the power of their brain and the power of their practice. And they know that, yes, spaced repetition is going to work. They know that, no, I'm not just going to read things. I've got to actually close it and retrieve it. Because, we've got to actually empower these people to learn. So I think that's partly our job. It's not necessarily just getting the subject matter across. It's actually helping each individual understand how to use their brains more effectively.